All right, I'm just going to finish on number 7, 8, and 9 from the notes. So given that a39 is a point on y equals x squared, show using the distance formula that a is equidistant from the focus and the directrix of the line y equals negative 1/4. So to get a little idea here, okay, so here's our point, 3, 9 on the parabola, and the focus is 0, 1/4. That's F. I got to figure out where to put that. The directrix is the line y equals negative 1/4. So that's L. All right, so the distance from my focus, which is 0, 1/4. So here's my parabola that actually comes down and hits, 0, 0. So the distance from A to F and from F to L, A to L, is equal. And that's perpendicular. So don't we already know the distance from the y-coordinate 9 down to the line y equals negative 1/4? Isn't that a distance of 9 and 1/4? So we already know that distance, so that's nice. So then all we need to look at is the distance from A to F. So A to L we already had, which was 9 and 1/4. So 9 and 1/4 equals, so A to F we're going to be looking at 0, 1/4 and 3, 9. So 0 minus 3 squared plus 1/4 minus 9 squared gives me 9, 3 squared here, which is 9. And this is 8 3/4. And so that's 9 plus, I got 12/25 over 16. When I did 8 3/4 squared and put it as a fraction. So then I made this 16 over 16. So underneath my radical I have 144 plus 12/25 all over 16, which is radical 1369 over 16, which is 37 over 4. Well, 9 and 1/4 is also 37 over 4. So they are indeed equal. Next one, number 8. Find the value of x for which the point x4 is equidistant from the point 0, 1 in the line y equals negative 1. So, all right, let's draw this so we get a better grasp. X and y, 0, 1. So there's 0, 1, and the line y equals negative 1. So it's like, you can already see this is the focus, and this is the directrix, so the vertex would be there, I would think. But I'm looking for finding the value of x for which the point x4. So I need to go over x and up 4. So 1, 2, 3, 4. So somewhere along here, this point is x4. Or over here, this point is x4. That distance from, this would be A, to F, and here's A to L. So that distance should be the same there or here. Those are perpendicular. So you can kind of figure out the distance here because it's up 4 and then you have this additional piece, so this is 5. So that's nice. So I know then that AL is 5 equals AF. So for AF, I'm going to be looking at 0, 1, at focus, and x4. So square root of 0 minus x squared plus 1 minus 4 squared. So 5 equals x squared plus negative 3 squared, which is 9. So there I got it. So now I'm going to square both sides, and I get 25 equals x squared plus 9. Subtract 9, and you get x squared equals 16. So x is plus and minus 4. And that should make sense. If x is negative 4, it's this one on the left. If it's x equals positive 4, it's the one on the right. And then the last one, label each item below on the diagram of the parabola. So here's the vertex, V. Here's the focus, directrix, L. So that's here. Point P. Well, I really wish this was A, but okay. That's the point, P. Axis of symmetry is right here. And the latus rectum is this one right there, the one that goes that length. I prefer this P point to be actually A because the distance here from F to V and V to the directrix, those are also equal, and they're the length of P. But that's okay for this example. I think that does it for the lesson. All right. Enjoy.